I didn't send you guys a update yet, but like I've already put the other videos on YouTube, so you guys can check that out. Okay. So just a recap from last class, right? Using a binomial distribution table. In many cases, we will be interested in the probability of a range of successes, right? In such cases, we need to use the addition rule for mutually exclusive events. For instance, for n equals 6, the probability of success is 0.5. We want to know what's the probability of four or fewer successes, right? So we want to know 4, 3, 2, 1, 0. So we have to figure out each one individually and then add them all together to get the answer. All right. So it would be quite a chore to use a binomial distribution form to compute all the required probabilities. However, table 2 from the appendix gives us the values of probability R for selected probability values and values of n through 20. To use a table, you find the appropriate section for n, and then use the entries in the columns headed by the probability values and the rows headed by the R values. So just to recap, right? Our n was 6, right? Probability of success was 0.50, and we just found it right here. This is for 4, 3, 2, 1, 0, right? The advantage of using a table is that if I have to find multiple probabilities, I can just add them up straight from the table, as opposed to me having to figure out each one individually and then added it all up. All right? Any questions on that? Okay. So table 610 is an excerpt from table 2 of the appendix showing the section for n equals 6. Notice that all the possible R values between 0 and 6 are given as row headers, right? So we're talking about this part right here. The value of the probability equal to 0.50 is one of the column headers up here. For n equals 6 and the probability is equal to 0.50, I'm sorry, go ahead. No, that's right. There's a reason for that. We're gonna talk about that. Yeah, they have the same probability. Yeah. It's because of the 0.50. Like 0.50 is like right dab in the middle. So that's why it's balanced on each side. Yeah. Oh no, no, you have it, you got it right. Yeah, it was like that on purpose. Yeah. Da, da, da. So you can find the value of the probability of 4 by looking at the entry in the row headed by 4 and the column headed by 0.50. So notice that the probability of 4 is 0.234. All right. Likewise, you can find the other values of the probability of R from the table. In fact, for n equals 6 and the probability of success equal to 0.50, here's what you have. The probability of R less than or equal to 4 is the probability of 4 plus 3 plus 2 plus 1 plus 0. You add them all up and then you get 0.89, all right? Alternatively, to compute the probability of R less than or equal to 4 for n equals 6, you could use the fact that the total of all the probability values between 0 and 6 is 1. And the complement rule, right? Since the complement of the event R less than or equal to 4 is the event R greater than or equal to 5, so that's just 5 and 6, you could add the 5 and 6 together and then subtract that from 1, and that will give you the same answer as the probability of 4. All right. Questions on this? Mhm. Yes, you can do that too. Of 4, 4, 3, 2, 1, 0 added up together. So all of them added up together should equal 1. So if you find it's easier to find 2 5, and 6, and then just subtract that from 1 to get the answer for 4, 3, 2, 1, 0 for everything else. Yeah, I got you. And then because of rounding in the binomial probability table, probabilities computed by using the addition rule directly differ, right, slightly from corresponding probabilities computed by using the complement rule. Okay. So, one second. Excuse me. Okay. There's another way that you guys can do this that I'd like to show you guys in the calculator. All right. Now, I have to use the big calculator because my little calculator doesn't do it. But if you have a 36X Pro, you can follow along. I'll show you what to do. Okay, so here's the question. They want to know what is the probability of R less than or equal to 4, right? In your calculator, the probability of R less than or equal to a number is equal to binomial CDF, all right? And then you put in your N, comma, P, comma, R, and that's it, all right? So for this question,
Can I do the I-36X Pro?
yeah, this is gonna be a binomial CDF. Your N is 6, your R, one second, I lost my mouse. Your R is 0.5. Excuse me, your P is 0.5. Sorry about that. And your R is 4. Okay. And after that, you just write the answer. So if you're using the 36X Pro, right, the first thing you got to do, you got to hit second, and then you got to hit the data button, all right? And then you want to go across to where it says distribution, DISTR.
Answer?
And no, then you want to go down until you get to binomial CDF.
Oh, C. What is the name?
Right. Then enter.
Then writing numbers.
Right. So remember that N is your trials. Right. For you, yeah. I'm gonna do yours right now. Okay. So if you're using the 83 or the 84 or whatever, right? You're gonna go second and then distribution. And then you want to go down to where it says binomial CDF. All right. And then you're just gonna enter in these numbers. So my trial was 6. My probability of success is 0.5. And my X value, remember, is the same thing as my number of successes, right? That's going to be 4. So it should come out like this, all right? Binomial CDF 6, comma 0.5, comma 4. Enter, and then you get the answer, all right? You could put 0.5. Yeah.
So I go second, I press second, then data, then cross distribution.
Uh-huh.
Go down to binomial CDF,
Uh-huh.
then enter, then the numbers in this case 6. But I don't know why. I got a 4.
It says normal, binomial CDF. Well, we're going to talk about that in a couple weeks. Don't worry. Mhm. You got it? Let me see.
I don't know how to get out of this when you. I don't know
Oh,
how to
second
rate
quit.
it.
Second quit.
Yeah, I know, but how I rate, how can I rate here?
Just go down and type over it.
Over?
Yeah, just go down and type over it.
No.
No, no, go up to where you want to erase and then just type whatever you want to put there instead.
Oh, because I have to press enter.
Yeah,
Enter it over again. When out there, I have to press enter and
yeah.
then.
And then you move to the next one. Yeah,
Oh,
always.
okay. Then
Yeah,
put the number. Oh.
yeah.
So 1, 5, and then 4, and then just enter again.
You're right.
But I always need to put parentheses, right?
No,
No, it don't
just put the numbers in. That's it.
and then enter.
Yeah.
But say probability,
What did you put for probability? What
is that the other? No.
it looks like an error message.
Yes.
Yeah, so what did you put for probability? What do I have for probability?
6.5.
0.5. And what did you put?
6.5 for
Let me see. So press clear.
clear.
All right.
6.5
So what's your trials?
binomial CDF.
No, where it says trials, what is supposed to be there?
Oh, okay.
What
Oh,
number?
trials.
What number's on the board? Where it says trials, what number?
0.890.
No.
Oh,
Where's trials? Tell me where trials is.
trials in this case.
Where's
Yeah.
trials?
Trials right here.
All right. So that's the N, right?
The N, the
So what
in.
so what number is N?
6.
Exactly.
And P is 0.5.
Exactly. And what's X?
4.
Right. So type that in.
6, so okay.
Yeah.
There. So
Enjoy it. Let's see. No, not you, not you. You don't need it. Your calculator can't do it though. Yours calculator can't do it.
but I'm going to scroll down and erase it.
You don't
And I
need to
can
erase it, just right on top of it.
right here. That's it.
Like just press down and then write 0.5. That's it. And then hit enter when you're done. Don't worry about erasing it. Just type on top of it and it'll go away by itself.
But I don't know how I go to the top.
You press up.
Oh, you see what is the question?
All right. So what's your trials?
6,
So six, and then what do you press after that?
0.4, 0.5,
No. What do you always
0.5,
press after you write down a number? What do you always press?
enter,
Enter. So write that. And then now do the next one.
0.59,
So 0 point. No. What do we have on the board?
0.5,
Write it.
enter,
Just write 0.5.
and then 4.
Why do you have 0.59?
4. Okay.
Like literally write 0.5. Enter.
Delete, enter, and then 4,
And then 4.
and then
And
enter.
then enter. Enter again. You got the
Not the
answer?
value yet. Here. Yeah.
So everybody good? So get a new calculator. I don't know, like if you want, you could borrow in the library. They have her calculator in the library, or you can go to the tutoring like lab and you could borrow over there. They have his calculator in the tutoring lab. Yeah. Or just use a table. You don't have to worry about nothing. All right. Everybody good? You can always review how to do this online. I'm gonna post it to YouTube. In the meantime, you guys try this. This is an example.
Oh, it's at 6 p.m. Like it's gonna be a lot of food in Roscoe Brown. It's at 6 p.m.
Good to know. Y'all
Yeah,
heard that? Roscoe Brown, there'll be food at 6 p.m.
yeah. Last call, but you need to do registration.
Just show up. Ain't nobody, there's people that register is not gonna go. I probably registered already and I'm not going because I have work.
Another,
Yeah.
so then Roscoe Bowl at 5:45, it starts 6 p.m. After this class, you can go because of just in the middle. He advised that.
If you like the event, stay. If you don't like the event, leave. You know? But they do have some cool events. I went to Passover today. Yeah, yeah. No, that was in Bliss Hall. Yeah, where they have the art gallery.
Uh,
Yeah, we have an art gallery on campus. Yeah. Yeah. It's in the back. Like when you walk out of Nichols, you instead of passing Meister, make a left. It's that building in the back. Tall building. No, no, it's further up. It's near Nichols. It's close to here. It's right next door to here, but in the back, you know? So instead of walking past Meister like you're going to Colston, make a left where the little parking lot is, and then just walk all the way straight back, and then that's Bliss Hall. Yeah, they. I didn't even know this, but they make ceramics here. I had no idea. Yeah, I didn't know. Yeah. So right next to the ceramics class, that's where the art gallery is. Yeah. Is yeah. My first time going to the art gallery, I was so mad,
Oh,
right? Because when I went in there, they had these pieces of art, and I was like, this stuff is so expensive. I'm like, how does BCC have the money to be buying art like this? That's what I thought, but this is what happened. It's actually students that made that. I was shocked. I don't know if they're selling it, but it was so good. Like honestly, if you told me that art was like $30,000, I would have believed you. Like it looks so good that I was mad that the school was actually buying art, you know? But no, it's actually students that made that. It was really, really good. Yeah.
Even like
Yeah.
looks expensive, but it's not, right?
No, it could be expensive
It could
because
be.
art is subjective. Like I'm saying that I would pay 30,000 for it, but what you call it? Carmen over here, like she has money, so she might pay like 1 million for it, you know? Yeah.
It is true, Herman.
Yeah. Yeah.
Oh,
It's an art is subjective, you know?
how did you feel when you finished,
Um, I felt good, like accomplished. Yeah. But then I started worrying about work. Like, where's work at? What am I gonna do now?
What was your first job? Here?
Nah, my first job, when I was in high school, I had like a little tutoring job that I was doing. That was my first job. Hey, what's up, man? Yeah.
The all in high school.
Yeah.
But I mean,
Oh,
doing your career.
wait, nah, you got class in the library, right? No, no, no. After this class, hey, also Colston. Dang. Yeah. So now we heard there's gonna be food in Roscoe Brown. A lot of food.
I got you. Yes.
All right. I mean, your professor probably cool. They probably let you eat in class, so yeah. Mhm. Yeah, yeah, yeah. I got you. You got time. I mean, you got spring break to catch up. Yeah. I updated them on YouTube, but I didn't have a chance to send out an announcement to the class yet, but I will later on. And I'm gonna upload this as well. All right, so we good? Oh, yeah, yeah. So I didn't get a chance to explain why I use a table because there's a benefit to using a table. Remember, we went through all that work just to get one problem, right? So when you have the table, you can have multiple answers and then you just add them together, and that's it. Instead of having to go through all the work to find the answer for one. Mhm. I got you. All right, so what's the answer to the first one? My voice a little shot. That's why I'm not reading the question. Otherwise, I would got you.
It's not like, what is the formula for this type of
I got you. So the probability of R is equal to N choose R times the probability of success raised to the R power times 1 minus the probability of success raised to the N minus R power. That's the formula.
how, what, and it's like the number.
What's N in this case? Good. What's P? Very good. And what's R? Yeah, that's good. So what's R? Okay, so what's the answer? Hmm?
What's the called?
Combination.
Combination. Six combination.
You don't got to do that. You can just look at the table and tell me the answer. Yeah.
But
The formula sheet. Mhm.
It's like the third page.
Yes, this is our formula sheet, right?
I had told you I kind of got lost something. Not lost, but
Yeah.
but I'm just thinking what
I got you or something.
10 to 6. Not over my problem.
Trying to remember. 10 and 6. Yeah. Was it a like a standard deviation question?
Well, kind of became 10 explanation point down 6.
Oh yeah, that's what that was. Yeah, that's what this was. But you could use a table and just figure it out, right? So we know our n is 6. So this is 2, 3, 4, 5. There goes 6 right here. Our probability of success is 70, right? So just go down to where the 6 is, right? This column right here, that's the 70. And I want to know what is 4. So go across the 4, and then bam, that's it. That's it. No, just 324. That's it. Easy, right? Or you could have used your calculator. Uh-huh. This is the problem up top. Oh, shoot. I'm so sorry. I'm here writing and y'all can't even see what I'm writing. No, no, no. Thank you for telling me. No, no, that's my fault. There you go. So you could use a table and just tell me the answer, or you could go in the calculator. You could have got it too. This one was the PDF, right?
Go to the end.
Right. After you figure out what the probability was from the top,
0.57. You got another answer.
it should be 0.324.
Yeah, and I got 0.579.
Not sure.
0.57.
You put the whole thing in the calculator.
I mean, these 0.7 and 4. It's not what I'm supposed to put.
Mhm. All right, so if you're trying to do it in a calculator, right? You go to the distribution, right? Which for in your case, remember, first you got to do second, data, go across distribution, all that stuff, right?
Yeah,
Yeah. So when you're in the distribution, you go down to binomial PDF, the first one.
CDF.
No, PDF.
Oh, P-O.
Right.
Oh.
Because remember, PDF is for R equals, CDF is for less than or equal to. Right? And then you just type it in 6, 0.7, and then 4. And then you get your answer. Same answer. Huh? All right. Let's practice it.
Good.
Yeah, that's good. Yeah. Yeah. You could definitely do this for your homework. You could like speed through your homework with this if you want. Yeah.
You're going back.
So borrow it again. You're fine. Yeah. Yeah.
You go back.
Yeah. This is being recorded, so you could always like borrow it again and try it later, you know? All right, let's look at part B.
So when I'm going to use PDF and when I'm going to use CDF.
EDF is for R equals. CDF is for R less than or equal to. This one's asking, what's the probability that at least 4 seeds will germinate? Which numbers are at least 4? So you know that n is 6, right? So I have 7 numbers in total: 0, 1, 2, 3, 4, 5, 6. Out of that set, which numbers are at least 4?
So, 6 numbers on the board.
At least 4. Like which numbers are at least 4?
So that's it.
No. Your set is 0, 1, 2, 3, 4, 5, 6. Which numbers are at least 4? 3 is at least 4?
I'm guessing. I don't know.
Which numbers? Like just get like list them out for me. Just tell me what they are. That's at least 4?
That's 4. That's 4 numbers right there.
No, but I want the ones that are at least 4.
For the 6 is 4, it's great.
4, 5, 6.
Oh,
All right. So this is the probability of R greater than or equal to 4, which is equal to the probability of 4 plus the probability of 5 plus the probability of 6. Right? Huh? No, 4, 5, 6. Yeah. So now all I have to do is just go to the table, find these 3 answers, and that's it. Or you could use a calculator.
CDF now. We're gonna
Now you use CDF. Yeah. Mhm. That's it. That's the answer. Yep, that's it. So let's look at the table real quick. So our N is 6. We kind of did the work on this already, right? So the column that I want is right here. But I want the numbers that are at least 4. So I want 4, 5, 6. Right? So I'm looking for these numbers, 4, 5, 6 going down. So that's what?
27.
That sounds about right. So 0.324 plus 0.303 plus 0.118. So it's these last 3 numbers in the column. Questions on this? Yeah. Of which one? Which one? The table.
Still see the other column?
Oh, for the table?
Yeah.
I got
We
you.
always need to use, we always need to use the table for that?
It's an option. You can use a table or the calculator.
Oh, it's tough. Okay.
Yeah.
The fact was like, from where she got 2, 3, 4? Or you
The
got
table.
from the table,
The
right?
table, yeah. Right here.
Okay.
Which game are you using?
So this is table 2, where it says binomial probability distribution. My n is 6, right? So here's n for 2, 3, 4, 5, and then here's 6, right? And then my probability of success at the top is 0.70. I just go down that column, and that's all I want is this column right here. And at the top of the page, looking for the probability, which is 0.70. And then you just go down the column, yeah. And then you're specifically looking for the numbers for 4, 5, 6. So that's the last 3 in that column. And we add it, and that's it. Good?
When you consider saying the probability of something is like.
So it's a probability that happens when you only have 2 possible outcomes, right? They sometimes call it success and failure. Just think of 2 opposites, up and down, left and right. That's essentially a binomial problem, you know? So you're calculating the chance that something will or will not happen, basically.
Less than.
Well, that's when you want multiple chances. Like let's say that we were going to take 6 free throws, right? Like it's basketball, right? So all I want to know is what's the probability of making 4 or more free throws, when you shoot it in. And then that's it.
Well, is it always such? And there's 2 outcomes, and it's asking like, what's probably less than or more than this?
Right.
Okay.
Yeah.
Well, that answer will be the whole thing, right?
When you add those 3 numbers together, that's the answer.
0.5.
Is that what you got? All right. That's probably right. No, there's more to it. That's all of it. Seven, 4, 5, right? Okay. Hey. So that's it. Let's talk about the calculator real quick before we wrap it up. All right. You're welcome. So let's say I wanted to do this in a calculator. I have a problem. My calculator can only do less than or equal to, it cannot do greater than. So how do I fix that? Right? You have to use the complement. So I can't find 4, 5, 6 in the calculator, but I could find 3, 2, 1, 0. Right? So that's what you're gonna do instead. You're gonna find 3, 2, 1, 0, and then subtract your answer from 1 to get this answer back. That's how you do greater than in the calculator. All right, let's take a look. So look, for the probability of R greater than or equal to 4, right? Which we said was the probability of 4 plus the probability of 5 plus the probability of 6, right? You have to do 1 minus the probability of R less than or equal to 3, right? So that is That's this part here. You're just gonna find 3, 2, 1, 0, add them up, and subtract from 1. All right. Said a little differently in the calculator, you're gonna have 1 minus the binomial CDF, where your N is 6, your probability of success was 0.70, but this time your R is 3. And then that's it. For you, you're gonna have to copy and paste your answer or write it down on a piece of paper and then do 1 minus that answer to get the answer back. All right. So let's take a look. So for me, I'm gonna do 1 minus, then you go second distribution, go down to binomial CDF. My N is 6. My probability of success was 0.7. And my X value here was 3 because I want 3, 2, 1, 0. And that's it. What happened? Oh, shoot. Let me do that. Let me do that one more time, y'all. Let me do that one more time. Sorry about that. I didn't realize I wasn't sharing the calculator. So what I'm gonna do 1 in the calculator, then minus, and then you're gonna go second distribution. Then you want to go down to binomial CDF. And then your N is 6. Your probability of success is 0.3. Your X is 3 because you want 3, 2, 1, 0. Just gonna paste it, and then there you go. That's your answer. 0.74431. It's okay if that's a little bit different from the chart, right? This is a more precise answer because I'm using the calculator. Okay. Questions? We good? I got you. I got you.
It's only equal, right?
Yeah.
Equal.
Let me just talk about 2 things real quick, and then we'll call it at that for today. So CDF is less than or equal to. PDF is equal to. So real quick. So what does a binomial probability distribution tell us? When a binomial probability distribution is used, we know the sample space of events consists of a fixed number of n of binomial trials. This means the trials are independent and performed under the same conditions. There are only 2 outcomes for each trial, success and failure. The probability of success on each trial is the same and is designated P for probability of success. The probability of failure on each trial is designated as Q, and it's Q is equal to 1 minus P, right? That's the complement, right, of success. The binomial probability distribution gives the values of the probability of R. The probability of R successes out of n trials for each R between and including 0 and n. The calculation of the probability of R depends on the probability of success of each trial, the value of R, and the value of n. Okay, go ahead. Yes, both of them. Yeah, exactly. Yeah, it's just equal to. Yeah. No, it's just for one of those numbers. Like if you wanted like just the probability of 5, that's the PDF, right? Yeah, PDF stands for probability density function, so it's just equal to 1. But CDF stands for cumulative distribution function. So that's the addition of all of them. Right? All right, this last part is going to help you with your homework. Because I know some of y'all got burning questions that y'all just don't want to ask right now. But I'm gonna just give y'all the answers right now. So here you go. Many times we're asked to compute the probability of a range of successes. For instance, in a binomial experiment with n trials, we may be asked to compute the probability of 4 or more successes, right? This table is going to show how common English expressions such as 4 or more successes translate to inequalities involving R, right? So this is the sauce right here. So look, if I say 4 or more, if I say at least 4 successes, if I say no fewer than 4 successes, or if I say not less than 4 successes, I mean R is greater than or equal to 4. So I'm talking about 4, 5, 3, excuse me, 4, 5, 6, 7, 8, 9, etc., all the way to infinity, right? If I say 4 or fewer successes, if I say at most 4 successions, or if I say no more than 4 successes, or if I say the number of successes does not exceed 4, that means R is less than or equal to 4. So I'm talking about 4, 3, 2, 1, 0. All right. If I say more than 4 successes, I mean the numbers that are bigger than 4, right? If I say the number of successes exceeds 4, it's the number is bigger than 4. So R is greater than 4. So now I'm talking about 5, 6, 7 to infinity. Right?
Where can we find?
This will be on the video. I got you.
Nah, like we don't have it like that. We have the
Yeah.
formula.
Nah, it's not a formal sheet. Yeah. Last one. If I say fewer than 4 successes, or if I say the number of successes is not as large as 4, that means R is less than 4, not including 4. So I'm talking about 0, 1, 2, and 3. All right. This is low-key the answer to all your homework. So have fun. All right. Any questions? You good? All right, I'm gonna call it at that. Yeah. You want the original question? Like this?
Yeah.
Yeah. It's just the A and the B. It's just the A and the B. That's all. Mhm. The A and the B. It's just the A and the B like questions. So what is the probability that exactly 4 will germinate? What is the probability that at least 4 seeds will germinate? Yeah. Oh yeah, come sign the attendance when you guys get a chance. How you feeling? That's good. Mhm. Yeah, it's okay.
I'm moving very slow.
I'm over here. I lost my voice.
Huh?
I lost my voice.
Oh, yeah, you
Shaking
sick?
my- I don't feel sick, but I've been coughing like the past 2 days, and I'm doing that tonight. Yeah.
It's familiar.
Yeah, I take that all the time. Hey, ready for you? Can I take this down, y'all? I just feel copy. It's like that. How you been? How's your week?
Wow,
It's good.
yeah. We didn't make time yesterday.
Oh man.
Yeah, there's a good one. It's very good.
Okay. Was it on mental health still, or did you?
No. It's kind of positive too.
Okay.
Okay.
Okay. Okay. Sounds good. You want to sit? Sit. All right, I can take it down now. You could either use a table. You could either use a table or you could use a calculator. Yeah.
Sure.
Okay. Yeah. All right.